A map drawn on gazelle-skin in 1513 appears to show the coastline of Antarctica. Ice core samples pulled from 3 kilometers beneath that same continent contain air bubbles sealed more than 1 million years ago. Those two facts cannot both mean what people say they mean. One of them is lie. The map belongs to Piri Reis, an Ottoman admiral who compiled it from 20 different source charts while stationed at Gallipoli. The ice belongs to the Beyond Epica project, a European drilling campaign that in January 2025 extracted a continuous 2,800-meter core from a site called Little Dome C, perched on Antarctica's central plateau at 3,200 meters above sea level, where summer temperatures hover around -35 degrees Celsius. Each single meter of that core compresses up to 13,000 years of atmospheric history into a frozen column barely wider than a dinner plate. And the question everyone keeps asking, did ancient civilizations map Antarctica before the ice, has a specific testable answer buried in the gap between those two objects. But to find it, you have to understand why the wrong answer became so popular in the first place. Because the wrong answer did not emerge from ignorance. It emerged from a book, a sliver of data, and the human brain's extraordinary talent for seeing patterns in noise. Start with the map. October 1929, Istanbul. The old Topkapi Palace, seat of Ottoman sultans for 4 centuries, is being converted into a museum. A German theologian named Gustav Deissmann, funded by the Rockefeller Foundation to catalog and preserve ancient manuscripts, is sorting through bundles of forgotten parchment in the palace library. Most of what he finds is administrative, tax records, naval correspondence, the bureaucratic sediment of empire. But one piece is different. A single sheet of gazelle skin, 87 centimeters by 63, dense with detailed coastlines, compass roses, and annotations in Ottoman Turkish. It is the surviving western third of a world map created in 1513 by an admiral named Ahmed Muhiddin Piri. The surviving fragment shows the Atlantic Ocean, portions of Western Europe and Africa, the eastern coast of South America rendered in remarkable detail for its era, and at the bottom, a landmass that curves eastward beneath South America's tip. The missing 2/3 of the map presumably showed the rest of the known world. What remains is extraordinary enough. Piri Reis's margin notes identify his sources with unusual transparency: 8 Ptolemaic maps, 4 Portuguese charts, 1 Arabic map of India, and 1 drawn by Christopher Columbus. That last detail matters enormously because no map by Columbus survives. The Piri Reis fragment may preserve the only partial record of how Columbus visualized the lands he reached. For decades after the map's rediscovery, that was the story. A fascinating artifact of Ottoman cartographic synthesis, a rare window into Columbus's lost work. Nobody made extraordinary claims about the southern landmass because, at the time, nobody needed to. It was understood as what it appeared to be, the South American coastline bending eastward, perhaps exaggerated, perhaps drawn from sources with imprecise information about Patagonia. This was standard for early 16th century maps. The edges of knowledge were routinely distorted. Then, in 1966, a professor changed everything. Charles Hapgood taught history at the University of New Hampshire. He had previously written a book on crustal displacement theory, the idea that Earth's outer shell could shift suddenly over the mantle, and Albert Einstein had contributed a cautiously supportive foreword. That connection gave Hapgood's subsequent work an air of legitimacy it might not otherwise have earned. In Maps of the Ancient Sea Kings, Hapgood made his central argument. The southern landmass on the Piri Reis map was not South America's coast. It was Antarctica. Not the Antarctica we know, buried under kilometers of ice, but the continent as it appeared when it was ice-free, mapped by a sophisticated prehistoric civilization that had navigated and charted the entire globe. The claim was electric. It implied that everything mainstream archaeology believed about the timeline of human civilization was wrong. that somewhere in the deep past, a culture existed with cartographic capabilities comparable to the modern era, and that evidence of this culture had been hiding in plain sight on maps scattered across the world's libraries. Hapgood went further. He argued that the topographic accuracy of the interior landmass was so precise that whatever ancient civilization produced the source maps must have possessed not only advanced navigation, but some form of aerial surveying capability. He was proposing a pre-Ice Age civilization with technology that rivaled the 20th century. It is worth pausing on the Einstein connection because it gets misrepresented constantly. Einstein wrote the foreword to Hapgood's earlier book, Earth's Shifting Crust, published in 1958, which dealt with the theory that Earth's outer shell might shift over its mantle. Einstein found the geophysical argument interesting enough to engage with. He did not endorse the ancient maps thesis. He died in 1955, 11 years before Maps of the Ancient Sea Kings was published. But Hapgood's association with Einstein was enough to give his later work a glow of scientific credibility, and every popular retelling since has leveraged that connection, sometimes implying Einstein endorsed the ice-free Antarctica theory directly. He did not. He could not have. He was already dead. The idea leaped from Hapgood's academic framing into popular culture through a series of amplifications. Erich von Däniken folded it into his ancient astronaut framework. Graham Hancock, in his 1995 bestseller Fingerprints of the Gods, made it a centerpiece of his lost civilization thesis. By the turn of the millennium, the claim that ancient maps showed ice-free Antarctica had become one of the internet's most durable alternative history memes, shared millions of times, debated endlessly, and almost never examined at the level of its actual evidence. Here is where the evidence starts to collapse, and the collapse is not subtle. Hapgood's primary comparison was between the Piri Reis map and a 1949 seismic survey of Queen Maud Land, conducted by a Norwegian-British-Swedish Antarctic expedition. That survey was groundbreaking for its time, using echo-sounding techniques that were just beginning to reveal what lay beneath the ice. It was also vanishingly incomplete. The survey measured less than 1% of the coastal area depicted on the Piri Reis map. From that fragment, Hapgood declared a match. 2 U.S. Air Force officers wrote letters supporting the resemblance, letters that have been quoted in every alternative history book since. But those officers were comparing the map to 1% of the data. When later researchers gained access to broader surveys, the supposed match evaporated. Geologist Paul Heinrich noted that Hapgood's methodology made a fundamental category error, confusing sub-glacial topography, which is what radar measures, with what a coastline would look like if the ice were removed. Those are not the same thing, not even close. But we will come back to that. Hapgood also identified 2 other maps as evidence. The Oronteus Finaeus map of 1531, a heart-shaped projection by the French mathematician Oronteus Finaeus, shows a large southern continent labeled in Latin, Terra australis recenter inventa sed nondum plena cognita, recently discovered, but not yet fully explored. Finaeus was referring to Tierra del Fuego, which Magellan had sailed past just 11 years earlier. But Hapgood insisted it was Antarctica. To make the shapes align, he had to rotate the image 20 degrees, relocate the South Pole by 1,600 kilometers, and accept a 230% scale discrepancy. The Antarctic Peninsula was missing entirely. Hapgood's explanation. Finaeus had to omit it because at that inflated scale, it would have overlapped with South America. Think about what that argument actually concedes. It admits the map does not match unless you physically remove one of Antarctica's most prominent geographic features and then claim the cartographer chose to leave it out for practical reasons. The moment you need to rotate, rescale, reposition, and explain away missing features, you are not reading a map. You are sculpting a narrative from raw material that does not want to cooperate. The third map in the rotation belongs to Philippe Buache, a French royal geographer whose chart of the southern lands is frequently dated to 1737 in popular accounts, but was actually published on September 3, 1739, a detail that matters because the earlier date makes the map seem more mysterious than it is. Buache showed a southern continent divided by an inland sea into two large islands, a feature that proponents claim mirrors Antarctica's sub-glacial structure, where East and West Antarctica are separated by a deep trough. The match seems compelling until you read what Buache wrote on his own map. The words conjecturie and soupçonner, conjectured and suspected, appear directly on the landmass. Buache was not transcribing ancient knowledge. He was developing a theory. He had observed reports of giant icebergs in the Southern Ocean and reasoned that they must originate from great frozen rivers flowing off mountain ranges on the unseen continent, exiting through straits that split the land in two. It was inventive, logical, and ultimately wrong. But it was his own deduction, not a copy of prehistoric cartography. So why does the myth persist? The mechanism is not stupidity, and framing it that way misses the actual lesson. The concept of Terra Australis, a great southern landmass, is over 2,000 years old. Aristotle proposed it in the 4th century BCE as a theoretical necessity, a counterweight to balance the continents of the northern hemisphere. Ptolemy agreed. So did Gerardus Mercator, who wrote that without a massive southern land, the world's structure could not hold together at its center. For 2 millennia, European cartographers drew this hypothetical continent on their maps because the physics of the era demanded it. Generation after generation, the shape shifted, the names changed, the coastlines were embellished with each new voyage report, but the presence of a southern landmass was constant. This means there is an enormous library of pre-19th century maps showing a continent at the bottom of the world. Not because anyone had been there, but because everyone was certain it must exist. When you then take any of those maps and compare them to the actual shape of Antarctica, you will find rough similarities, because both the hypothetical and the real continent occupy the same general area of the globe. The resemblance is structural, not evidential. It is like marveling that a weather forecast predicted clouds above an ocean. Confirmation bias handles the rest. You overlay an old map on a modern projection. You find a curve that matches, a bay that aligns, a promontory that seems familiar. You do not notice the bays that are missing, the coastline that runs the wrong direction, the scale that is wildly off. Your eye hunts for matches, and your brain rewards you for finding them. This is not a character flaw. It is how human perception works. The problem arises when the pattern matching overrides the method checking. Now, here is where the actual science arrives, and what it reveals is more precise and more devastating to the myth than any debunking essay. In March 2025, the British Antarctic Survey released BedMap 3, the most detailed map of the landscape hidden beneath Antarctica's ice ever produced. 6 decades of surveys. 84 new aerogeophysical campaigns. 52 million additional data points layered onto every previous measurement taken since the 1950s. The primary tool is ice-penetrating radar, aircraft firing radio waves downward through kilometers of frozen water until they strike bedrock and bounce back, revealing the silhouette of a hidden continent. But radar was not the only instrument. Gravimetry measurements detect mass variations in buried rock. Seismic stations record vibrations that map geological structures. Some of the earliest data came from dog-drawn sled expeditions traversing the interior. The most recent came from twin-engine aircraft fitted with instruments resolving features at 500-meter spacing. What BedMap 3 shows is staggering in its specifics. The average ice thickness across the continent is 1,948 meters. The thickest point is not where scientists previously thought, in the Astrolabe Basin of Adelie Land, but in an unnamed canyon in Wilkes Land, where the ice column reaches 4,757 meters. That is nearly 5 kilometers of frozen water sitting on compressed rock. Total volume, 27.17 million cubic kilometers. If every crystal of that ice melted into the ocean, global sea levels would rise 58 meters. Most of the world's coastal cities would cease to exist. And here is the detail that guts the ancient map comparison at its foundation. The bedrock beneath that ice has been compressed under unimaginable weight for millions of years. In some places, the rock sits 3,100 meters lower than it would without the ice pressing down on it. Remove that weight, and the continent would rise over thousands of years, a process called post-glacial rebound, still visibly reshaping Scandinavia 11,000 years after its own ice sheets melted. Sea level itself would be 58 meters higher, drowning the lowest features entirely. An ice-free Antarctica would look nothing like the sub-glacial topography BedMap 3 measures today. The map shows compressed rock under ice. No ancient chart can be compared to that. Every comparison between an old map and BedMap 3 confuses two fundamentally different things: the shape of compressed rock under ice and the shape of uncompressed land without ice. They are not even approximately the same. One is a measurement. The other is an estimate that would require modeling ice dynamics, mantle viscosity, ocean volume changes, and crustal elasticity across timescales we have barely begun to simulate. Now, in fairness, not everyone who finds these maps intriguing is a conspiracy theorist or a pseudoscience enthusiast. There is a legitimate question buried beneath the noise. Did pre-Columbian seafaring cultures explore further south than conventional history acknowledges? Polynesian oral traditions describe voyages into freezing southern waters. The Maori word for the southern polar region, Te Tai o Ruhi, predates European discovery by generations. And the precision of certain Renaissance maps, including features of the South American coastline that European explorers had not yet charted in detail, does raise real questions about the transmission of geographic knowledge from non-European sources to mapmakers like Piri Reis. Those questions deserve serious investigation. They do not require invoking a lost super-civilization to be interesting, but they get drowned out every time the conversation collapses into Hapgood's framework, which is rigid, falsified, and unfalsifiable in the way it shifts its goalposts. If you have been watching this channel, you know we take source disputes seriously. We have covered the same pattern-matching trap in the DNA and migration series, where surface-level genetic resemblances masked entirely different population histories. The maps operate on the same principle. Resemblance is not evidence. Context is evidence. And the context here is unambiguous. This is a good moment to mention. We are covering what BedMap 3 specifically reveals about Antarctica's most vulnerable ice zones in an upcoming video, including why the thickest ice might actually be the most at risk. If that kind of deep dive matters to you, subscribing means you will not miss it when it drops. Now, the AI question. This video mentions Grok, and the reason is straightforward. Over the past year, millions of people have fed these ancient maps into AI chatbots, Grok, ChatGPT, Gemini, others, and asked them to analyze the resemblances. The results go viral because the AI provides a structured, confident-sounding response. It lists the maps, it describes features, it notes visual similarities. And then, if the system is functioning properly, it provides the same scientific context I have described here. The 10-million-year ice minimum, the post-glacial rebound problem, the explicit labels on the maps themselves. But what gets screenshotted and shared is always the first half, the part where the AI catalogs the apparent matches. The second half, where the tool explains why these matches are coincidental products of a 2,000-year cartographic tradition, gets cropped out of every viral post, every single time. The algorithm rewards the mystery. The correction dies in the thread below. The AI becomes a prop in the same confirmation bias loop that Hapgood started in 1966. Not because the technology is wrong, but because people share selectively, and platforms reward the share. The deeper irony is that computational analysis of these maps actually strengthens the debunking. Overlay algorithms can quantify exactly how much rotation, scaling, and repositioning is required to force a fit between the Finaeus map and real Antarctic coastlines. Statistical models can calculate the probability that a randomly drawn southern landmass would produce the observed level of similarity, and the answer is far less improbable than it feels, because the landmass was always drawn in roughly the right part of the globe. So what is left once the myth dissolves? Not nothing, something better. The Piri Reis map is a genuinely extraordinary artifact, not because it shows Antarctica, but because it preserves the sole surviving fragment of a map by Christopher Columbus, a document scholars had considered permanently lost. It demonstrates that Ottoman naval intelligence operated at a level of cartographic synthesis that rivaled anything in Europe. The Oronteus Finaeus map is a masterpiece of Renaissance mathematical projection, a cordiform chart that balanced aesthetic beauty with geometric precision. The Buache map is a monument to the power of deductive reasoning from fragmentary evidence. Buache correctly predicted the existence of Alaska and the Bering Strait, using the exact same logical method he used to hypothesize Antarctica's split continent structure. He got one spectacularly right and one spectacularly wrong. That is not failure. That is science operating at the edge of available data. The real maps are more interesting than the myth they were conscripted into. They just require you to find the actual history of human ingenuity more compelling than the fantasy of a lost supercivilization. And the actual impossible thing is happening right now, not on parchment, under ice. The Beyond Epica team has extracted frozen atmosphere from before the genus Homo existed. Bubbles trapped in that core contain air from a world where glacial cycles ran on 40,000-year rhythms instead of the 100,000-year swings that shaped our species' entire evolutionary trajectory. Julian Westhoff, the chief scientist on the ground at Little Dome C, described the moment the drill hit the oldest layers, ice so compressed, so ancient, that each meter-long segment represented a longer span of time than the entire history of human agriculture. The lowest 210 meters, just above the bedrock, contain ice so deformed and possibly refrozen that its age may extend into the pre-quaternary period, beyond 2.5 million years. At Dome C North, 45 kilometers from the original Epica site, the Australian Antarctic Division is drilling toward ice that models suggest may reach 2 million years old, preserved at a resolution of 20,000 years per meter. The site was identified using ice-penetrating radar from the ICECAP Eagle survey and advanced ice flow modeling. Both the Australian and European teams began drilling operations in January 2025, working 50 kilometers apart, each using drills custom-built for the specific conditions at their respective locations. These are not metaphorical time machines. They are literal samples of ancient atmosphere, sealed in crystalline ice, waiting to tell us whether the carbon dioxide levels driving today's warming have any precedent in the deep geological past. Early results suggest they do not. The 2.7 million-year-old ice from Allen Hills, analyzed by the Princeton team, showed atmospheric carbon dioxide levels that never exceeded 300 parts per million. Today, we are above 420. The gap is not subtle, it is a signal. The ancient maps never showed an ice-free Antarctica. The cartographers who drew them were working with the best tools and theories their eras could offer, and they produced remarkable work. But the data being pulled from beneath that ice right now, core by frozen core, is showing us something the mapmakers never imagined: what an ice-free future would actually cost. 58 meters of sea level rise, the drowning of coastlines where billions currently live, a climate state with no analog in the last 2 million years of Earth's recorded atmosphere. The past that people imagined on old parchment is a comfortable mystery. The future inscribed in frozen air is not.